Hey everybody, so this will be our next set of notes that we're going to look at, which will be kind of our next big unit. And as you can see, it is our intro to functions. So simply, it says a function is a relation, which just means comparing two things, in which each element of the domain is paired with exactly one element of the range. For every input of the domain, there is only one output of the range. So a relation, like we said, is just a set of ordered pairs. They're being compared, they're showing how they change, one goes up, one goes down, or it may just be a bunch of numbers. But the really important part right here, for every input, there is one and only one output. That's going to come back into play later. So for a relation, I'm just going to make this up, bunch of numbers. So we do this curly little bracket where it's curly, and then a point, and then a curly. I'm going to say 0, 4, and I'm just making these numbers up off the top of my head. 1, -3. -4, -1. And last, we're going to do -6, 6. And then we're going to close off our set of parentheses with another one of those funky brackets. So your domain is always the first coordinate in an ordered pair. So that means it is the x coordinate. So our domain, our x's in everything we just wrote would be 0, 1, -4, and -6. Those are all the first numbers in each set of ordered pairs, so inside each set of parentheses. And your domain is also the independent variable. That's the variable we can change. That's the variable we pick. So the range, if we keep going, is the second coordinate in an ordered pair, and so it is your y coordinate. So if we look at the ordered pair that I just made up, our first y is 4, and then we have -3, and then we have -1, and then we have +6. If you need a little bit of help, remember, this is your x, that's your y. Your x always comes first. And so your range is what's called your dependent variable. Your dependent variable relies on the independent variable. That's why it's dependent. Kind of like how teenagers are dependent of their parents. So that's the basic talking about a function with a relation. Now there's 4 main ways to show a function. First one is a table. And so with your table, you're always going to have an x, you're always going to have a y. And with the table, you are basically just rewriting your ordered pairs, but instead of with parentheses, you're just writing them in a table. So it's pretty straightforward. So we had 0, 4, 1 and -3, -4, -1, -6, and 6. Pretty straightforward. Mapping is a little bit different. So I'm going to write my numbers in least to greatest order. So -6, -4, 1, should be 0, and then 1. So here is my x's. Over here will be my y's. So I'm going to also write my y's in least to greatest order. So -3, -1, 4, and 6. And I will go ahead and tell you, mapping is my least favorite because I think it makes it super, super messy. But what you literally do is you just draw a line to connect the different numbers that go with each other like this. Okay? Yeah, it can get really messy, but later on you'll see it actually makes it really easy to see what would be a function and what would not be a function. When we get into graphing, that's where we just graph our coordinate points. So our first was 0, 4, so I'm going to go over 0 and up 4 right there. Our second one was 1, negative 3, so I'm going to go over 1 and down 3. Our fourth point was negative 4, negative 1. I'm going to go over 4 and down 1. And our last point was negative 6, 6. So go over negative 6 and up 6. We graphed all our points. Cool. And ordered pairs, I'm not going to make us rewrite all those, but just remember your ordered pair is an XY. We already wrote those earlier. So when you have a function and it's given on a graph, you can do what's called the vertical line test, is where you draw literally a vertical line through the graph. So if the vertical line hits the graph one time and only one time, then it is a function. If the vertical line hits the graph more than one time, then it is not a function. A really easy mistake people make right here is the x and y axis. X and y axis, they're not part of the graph. They're just there to show, okay, this is where the zeros are and this is where the lines of the graph are. So if I look at our first example, I like to do this with a highlighter tool so I can still see what's going on. If I take and I draw a line through each point on my graph right here, I can see that right here, those dots hit that green line twice. So that means this is not a function. Okay, if this dot wasn't here, then it would be a function. But that's what throws it all out of whack. Let's get our highlighter again. Draw my lines again. Okay, we see in a couple spots, right here, here, here. We could keep going on too. Those all make it not a function because my green line that I drew through the graph hits it more than once. So let's look at this next example. Now I can draw my line here, hits it once, hits it once, hits it once, keep going, hits it once, hits it once. So all of these right here where it hit the graph, those tell us, because they all only hit one time per the green line, that this is a function. It is a function. And then the last one over here. If I do my green line right here, it hit it a bunch. It hit it here, and here, and here, and here, and here. You get the point. It hits it all the way down for infinity. So this means it is not a function. The vertical line test is meant to be really easy. Don't overthink it, because you just literally draw a line and say, okay, did it hit the graph once or did it hit the graph more than once? That's all you're looking at here. If we go to our next page, a solution set. We've already looked at a solution set, believe it or not. A solution set is ordered pairs that make a true, we're going to put statement here, but up above it, we're going to put a true function. So it tells us the domain of, right here, you read that as f of x, and we talk about that here in a little bit. Read that as f of x equals 2x minus 1 is negative 1, 0, 1, and 2. So these numbers right here, that is the domain, which means that is my x values. So if we read our directions, it says to substitute each value of the domain into the equations. Well, substitute means where you replace. So we're going to simplify each equation separately. So I'm going to take my first one. And we know our function is 2x minus 1. Well, instead of x, I'm going to replace it with negative 1. So 2 times negative 1 minus 1. And you know what? Well, we can do it by hand. That's okay. We know 2 times negative 1 is negative 2 minus 1. And then negative 2 times 1, negative 2 minus 1 is negative 3. Okay, if we keep going, we would have 2 times 0 minus 1. Well, 2 times 0 is 0. Minus 1, 0 minus 1 is negative 1. Okay, keep going. Then we would have 2 times 1 minus 1. Remember, I'm getting these numbers from right here because it told me so. Those are the numbers we're using. So 2 times 1 is 2 minus 1. 2 minus 1 is just plain old 1. Last one. 2 times 2 minus 1. 2 times 2 is 4. Minus 1, and we get 3. So it says, what is the range? Well, all these numbers down here, those are my y values, which means they are the range. So we would have negative 3, negative 1, 1, and positive 3. So then it says, write your answers in a solution set. Well, for my first x value, we had negative 1, and we found out that negative 3 goes with negative 1. My next x value was 0. We saw that we got negative 1 when we plugged in 0. My next one is 1, and when I plugged in 1, we got 1 out. My next x value was 2. When I plugged in 2, we got 3 out of our function. So there is our solutions in a solution set where they are wrote as coordinate points. So what we just did was called function notation, which is a method of writing algebraic variables as functions of another variable. Most often, functions are portrayed as a set of, you guys can guess it, x, y coordinates, with the vertical x-axis serving as a function of x. So, for example, writing f of x equals 2x minus 1 is the exact same as us writing it as y equals 2x minus 1. Those are saying the exact same thing. Don't get caught up in that. But what we have right here would be our function machine. So up here at the top with your x, that's your input. That's what we got to put inside our machine. And so this would be the f of x. And so the x is the true input. Our function is 2x minus 1 because they told us. And so then what do we get out of the machine? We get an output out of the machine. So that would be like f of x equals some sort of number. And that number is going to be the output. So down here, put a little star. I want you to write f of x is read, well, f parenthesis x, close the parenthesis, as f of x. And if it has a j, you would say it as j of x. Or as a g, you would say it as g of x. So our next part, I'm just going to do one, or I'll do a couple of these. It says if f of x equals 4x minus 2, then find each of the following. So all we have to do right here is take this and replace whatever number is inside the parentheses, this, for the x. So instead of writing 4x minus 2, I'm going to write 4 times 0 minus 2. Well, 4 times 0 is 0 minus 2. That turns into negative 2. if I do the next one, instead of having 4x minus 2, I'm going to have 4 times 3 minus 2. Well, 4 times 3 is 12. Minus 2 from 12, we end up and get 10. You guys do those last two. Pause the video and do those two real quick. Hopefully you are done by now. So we would have 4 times negative 1 minus 2. Well, according to PEMDAS, we would multiply first. So 4 times negative 1 is negative 4 minus 2. Negative 4 minus 2. We're getting further and further down the negative number line. So that would be negative 6. Last one, 4 times 10 minus 2. 4 times 10 is 40 minus 2. We get 38. We are about done. We only have a couple more problems I want to do. This one is really important right here because this is where we make a really easy, simple mistake, but it's really easy to avoid. But all we have to do is use parentheses. We gotta use those parentheses. So it tells us if g of x equals x squared plus 2, find each of the following. Well, if I do 2 squared plus 2, well, 2 squared, this is like doing 2 times 2, which that is 4. Well, 4 plus 2, that's 6. If I keep going, I do negative 3 squared plus 2. That's like saying negative 3 times negative 3. Well, a negative times a negative is a positive. So I would do 9 plus 2, and that's 11. I can show you right here in the calculator too. If I do negative 3 squared with no parentheses, we get negative 9. But I just told you a second ago that it's a positive 9 right here. If I put my negative 3 in parentheses, we get positive 9. So I don't care what number it is, whether it's positive or negative, you gotta use parentheses. Next one, if we keep going, we're plugging in 0. So we would have 0 squared plus 2. Well, 0 times 0 is just 0. So 0 plus 2 is just 2. And last one is 8. We would have 8 squared plus 2. Well, this would be 8 times 8. 8 times 8 is 64 plus 2. And we get 66 as our answer. So all we did was plug all those in. And really, you can plug them in the calculator just like this, where I square it and then I add 2. You don't have to solve them by hand like I did. You can plug and chug it in the calculator, and there's nothing wrong with that. But this next part. When given an output first. Now this is where we're going to do this last two, and then we're going to stop. When given an output first. Well, I know that I'm given an output first right here because this negative 4 is outside the parentheses because it says f of x equals negative 4. So what I'm going to do is we are going to set the output equal to the function. So I would take my function, negative 3x plus 5, and we are going to set it equal to my output. So I get negative 3x plus 5 equals negative 4. We know what to do right here. We've been doing this for a while now. We do our split. Negative 3x comes down. 5 goes over, becomes negative. Negative 4 drops. Negative 3x equals negative 9. Divide by negative 3. Divide by negative 3. And so we get x equals positive 3. So you can write your answer like that, or you can write it like this, f of 3. I don't care which way you write it, but they both mean the exact same thing. So take a quick second. You guys try and solve the second one. Okay, hopefully you paused the video by now and you already solved it. So if we do, we're going to take our function right here, so negative 5x plus 5, and we are going to set it equal to our output, negative 10. We go ahead, we do our split, negative 5x, the 5 comes over, becomes negative, minus 10, negative 5x equals negative 15, divide by negative 5, divide by negative 5, we get x equals positive 3. And we are going to stop right here. We'll continue doing the rest of this later. If you guys have any questions, feel free to shoot me a message and I'll try my best to get back to you. Thank you.